We can try to solve this by isolating the g prime. So if I do that, I get g prime of x is equal to the square root of g of x, and I can integrate both sides, and I end up with this expression for g on this side. However, the problem is here, if I want to try to integrate this, I have an embedded function inside an integral. I cannot just use power rule to integrate this. So I need to choose a different strategy here because I'm stuck. I won't be able to anti-differentiate that expression. So what we can do is we can maybe generate a derivative, and that would free up that g prime out of there, and it would also generate a g prime expression. So watch this. So as I differentiate, I can differentiate this implicitly. So I end up with 2 times g prime of x, and then apply chain rule. So I have to differentiate the inside function, so I get the second derivative, and that's going to be equal to the first derivative. Okay. Now the nice thing about this expression is then that we've actually got the same factor, g prime, on both sides, and we can actually eliminate the g prime from both sides. So I have a new equation that looks like this. 2 times the second derivative of x is equal to 1. Or in other words, the second derivative is the constant 1/2. Well, I have enough information here to be able to anti-differentiate and solve for the 2 plus c's that's going to be generated going from the second derivative back to the original function. So I can anti-differentiate this to get g prime, and that's going to be equal to 1/2 x plus c. And I can just plug in, I can't plug in because I don't have a g function, but I'm going to anti-differentiate this again, and I'm going to end up with 1/2 x to the power 2 divided by 2 plus c times x plus another c, which I'm just going to call k. So I now have an expression for g. I'm just going to simplify this. X squared over 4 plus cx plus k. And I don't know c or k, but I have two equations that I can generate based on these equalities here. G is 0, g of 0 is 0, g of 4 is 4. So plugging those in, g of 0 equals 0. That means I have 0 squared divided by 4 plus 0 times c, so that's going to be plus 0 as well, plus k is equal to 0. That means that k is equal to 0. So my equation now looks like this. G of x is equal to x squared over 4 plus cx plus k is equal to 0, so I'm just going to leave it like that. So I've used this to generate that. I'm now going to use the other relationship. G is 4. G of 4 is equal to 4. So G of 4 is equal to 4, which is equal to 4 squared over 4 plus c times 4. Okay, so there's my 4 and 4. I can solve this equation for c. So here I end up with 4 is equal to 16 divided by 4 is 4 plus 4 times c. In this case, c is equal to 0 as well. So my g of x function is equal to x squared over 4. What I'm looking for is g of 1 is going to be equal to 1 over 4. So the answer is A.